What's up, guys? What's up, guys? Welcome to another JoCademy video. Yep. Okay, so what we'll be learning today is, hold on, sine, cosine, and tangent. Yeah. So let's learn what sine, cosine is. Basically, right triangle. Hold on. Let me see something. Okay, so basically, triangle. Whoa. Triangle kind of look like this one, right? That's a triangle. This is a triangle. But we'll be focusing on a specific type of triangle, and it's called a right triangle. Why is it right? Because the angle formed over here is a right angle, and therefore the other sides of these two sides will add up to 90 degrees, because the sum of angles of a triangle is 180. So if this is 90, these two have to be 92. Okay. Alright, what was I? Triangle, right angle. Yeah, you know that. This is called the hypotenuse. This is called a leg. This is also called a leg. And you probably know an equation: a squared plus b squared equals c squared. Pythagoras theorem only works on these type of triangles, right? Today we're not here to explore explore that. Today we'll be understanding what is sine, cosine, and why it relate to this. Yeah? Okay. Okay, so here's a circle. Alright? Let me draw that bigger. Hold on. Okay, that's good. And the center would be right here. And if this were the center, and I drew a line out to the other side, to one point of the circle, this would be called R for radius. Okay. Yeah, so why this relates to sine cosine is oh my god, hold on. Okay, so back to what I was saying. Circle, radius, and so basically what sine cosine is, it relates to circles and triangles. Okay, so let's say R also, like, okay, pretend this R wasn't here. Okay, let's say this R started pointing over here, like 2 o'clock, and we'll call this R. We'll call this 2 o'clock R, like a clock, 1, 12, whatever, 2 o'clock, no matter. And so, like, what if you want, what if we want to know some stuff, like for some reason, well, I mean, what the flip? Yo, what the flip? How'd that happen? Right? Like, it's still the same R as if, okay, hold on. As if R was this, right? It's still R, and it's equal to this R, and this is still equal to this R, and this is equal to this R. That's R. This is R. So like, what if R was the hypotenuse of a right triangle, right? You know? And so, hold on, this relates to sine equation, right? So like, what if R, let's pretend R was 1, right? And like, you have R, and like, a hypotenuse, a slanted line, like, we all know lines on a graph, like, they can go like that, that's like y equals x or something like that, right? But then, this line is made up of runs and rises, you know? Boom, 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 you know? And these are all equal, by the way. Like, the ratio between these two are equal. That's the slope, which is this line. And so we get the slope of R, right? And these thingies are like sine and cosine, you know what I'm saying? Like, you know, like let's say this is some angle, because on a circle there's angles and stuff. Let's say this is like an angle. This is some angle, and angles are marked as this Greek symbol named theta. Theta. Remember it. Theta. T-H-E-T-A. Theta. Let's say it's marked as some angle theta. Hold on. Alright. So, let's mark some angle theta. Just like how this right here is also marked theta, though. And why this is at 90 degrees is any slanted line will have a rise and a run, and that cannot be another slanted line that also has a rise and run. And because these are different dimensions, these are 90 degrees apart from each other. Every dimension, 1 dimension, 2 dimensions, 3 dimensions, are 90 degrees apart from each other. Also, did I forget to mention this video is made for Colin Wu, because he doesn't know how to use a calculator on decimals. Anyways, what was I saying? Alright, sine cosine, right? So, basically, sine cosine, right? So this is theta. This made some angle, right? And this angle is related to how big this right here is. Cause look, hold on, erase this real quick. Alright, so if let's say I decided to use this as my radius, or yeah, this, believe it or not, is the same length R, but this and this are not the same length. This length is not the same as this length, and this one is not equal as this one, and so is the angle. The angle theta here is not equal to the previous thing, but what is the same is R, right? So know that the angle is related to the length of the legs, but not the R. R will always be the same. Alright? The radius is always the same. And so, on a circle plane, you know what planes are? Like these thingies, you draw graphs on it. On a circular plane, where circles are existing, it goes, you know how in normal graphs it's like x, y. Well, in circles it's cosine and then sine. Therefore, sine is this top side right here, and cosine is this top, is flat, yeah. And cosine and sine right here, cosine. But you also may know that if it were this angle, if we were getting the sine cosine of this angle, this would just only be sine and this be cosine. But oh my god, hold on. Yeah. So okay, what is this? I swear we heard it. Hold on. Alright, hold on. Okay, so basically saying, if we're gonna look at the angle here, right, then sine has to be the top and cosine is the bottom part, right? So we're gonna be looking at these angles. But if you look at this angle, this be sine and that be cosine, and if we've like kind of like rotated around and stuff, like if it were like this or something, like I think, I don't know. Yeah, if this is the angle and we're looking at this angle, that means sine would be here, cosine here, right? What am I wrong? What am I doing? Anyways, I don't know what I'm doing anymore. Just know. Yeah? Okay. Okay, back to what I was doing. So anyways, now we know, if we have this angle right here, the angle that the leg is on, like, is gonna be cosine. This is the cosine. Oh, I forgot about talk about tangent. My bad. And the opposite, which is this one, never the hypotenuse. Okay. Cosine and sine are always about the legs that are perpendicular, right degree angle. Okay. Never the hypotenuse. And you're gonna be like, what's tan? Well, tangent, like I was talking before about the graphs, like this thingy, tangent is the ratio between cosine and sine, so it's sine over cosine, that is equal to tan. And if we went back to the circles, we would know that tangent would be the slope of our line, but more importantly the angle, the thingy right here. And tangent, if you know what that means a tangent line touches one point or something like that, and tangent is the slope of that line, you know. But we don't care about that so far. Anyways, so let's get to some problems real quick. Let's see. So let's hypothetically speaking, oh whoops, my bad. Yo, my bad again. Okay, hypothetically speaking, what if we have like some zip line thingy. Alright, so I'm back. So let's say we have a zip line. Alright, this is like the top of the zip line post, right? And this is the zip line, the line right here. And it like goes down all the way to the other side, the platform part, like right here. It'll like probably be like that. Let's be honest. So like, you know, the zip line there. And we know that the angle from here is 10 degrees, and we know that it's 25, like right here, between here to here is 25 meters. So now it's Oh, like I'm saying, so we know the distance between the thingies are like 25 meters, makes a 10-degree angle. So now it's asking, what's the length of the zip line itself? And some may think, well, what is it, 25 because you travel 25 meters? No. So if you laid out this slat as a straight line, it'd probably be like longer, like that. So no, it's not 25 meters. So to find this, we do, well, let's look. We'll try to look at this, find a hypotenuse, and we're given an angle, and we're giving the length of the side piece that is touching the angle. So that means that's cosine. Cosine 10 degrees equals hypotenuse h over, this would be cosine, so we like 25. And so you multiply to get solve for h, you multiply 25 to cancel out 25 and put 25 right here. So 25 times cosine 10 degrees equals h, or hypotenuse, yeah. Alright, let's get on Desmos, hold on. Alright, so we're on Desmos. Wait, hold on. So we on Desmos, and look at that, 25 cos. That's a pretty cool graph, I'm not gonna lie. But I'm kidding. 10 degrees. And make sure, if you're using Desmos, click on this wrench on the side. And you see there's radians to degrees. We'll put on degrees. So the answer to this is 25.62. Alright? Okay. Let's do one more problem. Okay. So I do want to note that the only hard part about doing sine and cosine is differentiating which one you're gonna use. Okay? Because solving for it, once you know what to do, I'm sorry for cosine. You just do the stuff and you're like, that was easy, hypotenuse over whatever, blah blah blah. It's same thing for sine and cosine. They're basically the same method. That's not, I mean, if it's the other side, like, let's say we're solving for this angle, right? If you were to rotate this triangle, where, like, 90 degrees counterclockwise, it'd literally be like this, where sine is now the cosine because here, and now it's on the side, now cosine's on the top. So really, they're interchangeable, just depending on the angle you're doing. And once you know what you're doing, the same process, but we're gonna do one that uses tangent. Alright, so let's say you're a little guy right here, a little man. Why is the eyes going? Okay, so let's say you're a little guy, you got a tripod right here, you got a little camera right here, and you're standing on the floor, by the way, and you're trying to take a picture of a tower, right? And so you know the distance between you and the tower, around 50 meters, and you're looking, and your tripod's like angled right here. Oops. And you're using some app on your phone, like the measurement app on your phone, and like you hold your phone, align yourself with the tripod, and you look up to where your tripod's at, and your phone gives you 82 degrees. So that means your tripod's at 82 degrees looking up, right? So basically, if I were to put this 50 meters up here, like that. By the way, your tripod is about 1 meter tall. And so now it's asking, actually, your tripod's looking all the way up here, by the way, not here. All the way up there. So it's asking, how tall is this tower if given that this is 82 degrees and this is 50 meters. Maybe well, I don't know. Well, tangent, you a sine of a cosine, meaning we already know the cosine of the thing right here. That's 50 meters, and we have the angle. So solve for sine, or the length of this, the height. Just do tan 82 degrees equals sine of x. Actually no, sine of 10 degrees and 82. By the way, when I mean sine over cosine, I mean the angle is the same as the angle here. You know, cos of 82 degrees. Right? But let's pretend you didn't know that. You didn't know that's tan, the sine, whatever. What you knew was only what's after the product. So, let's say this is height for h, but not to mistake with hypotenuse. And this is x. To solve for h, you just do x times, cancel times on the other side. X times tan 82 degrees equals h. X is equal to 50, so it's 50 tan 82 degrees equals h. And hold on. And so we're back to 50 times tangent 82 is about 355.76 meters. Yeah. If you're asking where do these numbers come from, like what is tan 82? I was saying earlier with the graph, I mean a circle. Alright, let's see if this is a circle. So sine, cosine starts with a circle with radius 1. So let's say this is the radius from here to here. Alright? Okay. So basically, what if we had y equals x? This makes some angle, right? And then we have x equals 1. Like 0.5 times, or 0.6. Let's try 0.6. And you have y equals 0.6. Right, nope. Like that. So you have this angle. Actually, hold on. This is 0.7, my bad. Nope. Okay. 8. Okay, but realistically, let's say we drew a line exactly here, 0.707. So, yeah, that's more correct. Look. So, you don't know this angle, but, you know, but it starts with a radius 1 circle, or, yeah. And so, if it were to have something, like, had some angle, like y equals x, y equals 0.5x, you see how it changes? That increases in the angle. 2, 3. See how it changes its angle, right? So this x will correlate to whatever angle y equals x is at this angle with a radius 1. But basically, this number is basically the length it's at if radius 1 was, you know, that. And so so we know that this is cosine, right? Sine of some angle, like some angle, is equal to 0.7 over 1, or 0.707 over 1. Now, to find the angle, all you have to do is do the reverse sine, which is denoted like that, of 0.707 over 1, which is around 44 degrees, 45 degrees, you know? So like, that pretty much checks out, bro. Like, what can I say? Yeah, no, if it's confusing, my bad, gang. I think I'm on something right now.